Hi, welcome to the statics tutorials. So with this problem, we have two blocks that are stacked together. A and B have a coefficient of friction between each other of 0.252, and that's our static coefficient of friction. A and B are also resting on a rough surface, and the coefficient of friction between B and that surface is 0.102, also a static coefficient of friction. So we're going to pull on these two blocks here at this top right edge and see what the smallest force is to cause impending motion. So we've got a couple of different cases that can occur. Case one is that B stays in place and we just slide A over B. So drawing this free body diagram here just of A, we have the weight of A acting down. We have the normal force from the contact of A and B acting up. We have our force going in this direction. And so without friction, this block would slide in this direction. So we're going to have friction opposing that relative motion. Looking at the sum of forces in Y, we have the weight acting down, and then we have the normal force acting up. So we can calculate that the normal force is 981 newtons. Because we're assuming that we're at impending sliding, then we can say that the frictional force is equal to that coefficient of friction at the bottom of A times NA, and that gives us 247 for that frictional force FA. Then we can do sum of forces in the x direction and get minus 247 for FA plus F is equal to 0. And we'll get that F is equal to 247 newtons. But we also need to look at the case where we have A and B sticking together, and when we pull on them, they slide not over each other, but they stay stuck together, and the whole thing slides where B is touching the surface. So now we're going to draw our free body diagram where we're showing them together. So we're using the combined mass of 200 kilograms, using the combined distance of 0.6 meters here as the height, and really do a similar kind of process that we did over there. So we have our sum of forces in the y direction, we have our weight acting down, and then we have NB, the normal force that's at the bottom of block B in the positive y direction. We can solve for NB and get that that's 1962 newtons. We can then go ahead and use the coefficient of friction here, or 0.102, with that NB force and solve for the frictional force and get that it's 200 newtons. And then we can do our sum of forces in the x. We have our negative 200 newtons for frictional force. We have our applied force F here, and so F has got to be equal to 200 newtons. And let's look at this last case. It looks unlikely that A would tip over B, but since we do have some height here with the stack, it might be possible that A and B would stay stuck together and both of them would tip over this point here. So here's our free body diagram for tipping. In the limit of tipping, the normal force at B would be right at the edge. So I'm calling that point C, and then we'll do a sum of moments about C. The normal force is right at C, so it can't contribute a moment. The frictional force goes through C, so it can't contribute a moment. You have the positive moment generated by the weight here. Oops, forgot my unit there of newtons. And then you have the negative moment created by the force F times the total height of the 0.6 meters. So solving this, we get a force F of 818 newtons. Now that we're done solving these three cases, we have to go back and compare the different force values that we got for F. So we had 818 here, we had 247 here, and then we had 200 newtons here. We want to see which one is the lowest. In that case is our 200. And this is the case that will occur. Once we get to 200 newtons, we're at impending motion. We've answered the question. We're not going to get up to a higher force of 247. We're definitely not going to get up to a higher force of 818. Again, if this is on an exam or a homework, you want to clearly mark which of the three cases is going to occur. so that you're showing the person who's grading your work that you understand which of those three, and then make sure that you write a note. So we could write a note something like this: impending sliding of B over the surface, to indicate, yeah, this is definitely the case that occurs. Thanks for watching.